Hi friends, continuing our discussion of the operating systems. Now let us see the need of a bus system while connecting the various components of a computing system with the CPU. The need for bus system arises because the number of pins available on any CPU is finite in number or limited in number, whereas we require unlimited number of connections to be done, as we discussed in the previous session. So any uh, say memory, any element in the memory can be identified through an address, and then the data can be collected. So for every interaction between CPU and any component like memory or any IO device, we do require three connections: one for identifying the address, and one for the data transfer, and one for controlling what type of action to take place. Is it a read action, write action, and so on. So synchronizing with time, what actions to be taken and all that. So address, data, and control lines are required to be connected from every CPU to each of the components in the system. So to make sure that each one can be connected individually, then you can imagine how many pins are required. Say, for example, if we are talking about a 64-bit processor, it means that it can any given time take input of 64 bits or give an output of 64 bits. So it interacts with neighbors with an data of 64 bits at any given time. So if each of the device wants to interact with that, then between CPU and each of the device, we do require 64 bits or 64 lines of connection. Say if there are thousands of various components in the computing system, then thousands of 64 lines need to be connected to the CPU, and that makes it impossible for making a chip with thousands of 64 pins available. This is only for the data component. Same way, if we talk about address component or talk about control component, then each one has to be separately done. Then the number of connections, the number of pins required on the processor chip grows exponentially large, which is impossible to work with. And another important thing what we see, or a relaxation for this problem comes when we know that only one processor is there, and one processor can interact with one of the components at any given time. It cannot interact with all the components simultaneously because there is only one processor to work with. So since there is only one processor to work with, then there is no point in having a separate connection for data connection for memory, separate control connection for memory, separate address connection from memory, separate read write connections to the memory, and on the other end, if we are reading from the memory, then separate data connection back to the processor. And same way with the each of the IO devices, we don't need a separate address, separate data connections to be done. So it saves a lot because at any given time, only one of the components and one of the operations pertaining to that component is uh, possible to be used, only that can be used. Therefore, there is no point in having all wires connected to each one. So instead of that, we can go for what we call a bus architecture, where all the elements are connected in parallel. All the elements are connected in parallel, and whichever component the CPU wants to communicate with, so through the address line, only that particular component is made live, and all other components will be in sleep mode. So only one component that is required for communication will be kept alive, and all other things will be in off state. And this way, the address bus will allow only one of the components to be active and all other things to remain inactive. Then the control bus will tell to read or write. So because only one element is active because of the address bus, so whatever signal is given to the control bus is read by only that particular component which is alive, and all other things are in sleep mode, and hence they cannot respond to whatever control signal is coming. And the data is connected only to the component which is live at any given time. So through this arrangement, we can reduce lot of redundancy, lot of extra wiring and all that, and that definitely simplifies the design. So we know that any given time, only one of the components is going to communicate with CPU, because there is only one CPU that can communicate with the neighbors. So the CPU has to communicate with the neighbors, and one CPU means any one of them should be communicating. Therefore, no point in connecting each components individually separately to the CPU. So we can make all the connections in parallel and keep only one element active and all other to keep inactive. So this is done through enable and disable uh, activity, and this address bus will enable a particular component, and then the control bus will guide whether to write or read or whatever activity. And because in all the components only one component is active, all the activities are done by that particular component, and hence the designing becomes simple. So we are going to save a lot of connections, therefore it is going to be highly cost effective and scalable. So when you want to add any new device, just connect to this bus in parallel. So three connections need to be added to this bus for every element. So for every component, three connections have to be done to this common bus, one for address, one for data, and one for control. So it becomes quite easy for changing the size. So adding more devices doesn't need to change any uh, design. So just it becomes simple to scale and highly flexible. So anytime anything can be inserted into the system, anytime anything can be removed from the system. So it becomes highly flexible, and we make use of efficient use of the resources is possible through the bus system. So that's why we go for bus configuration while creating the connectivity. So when you are organizing a computer system, so we have many components, and all the components can be connected in parallel through the bus arrangements, and this will simplify the design. It becomes cost effective, it is highly scalable, more flexible, and efficient use of resources is made possible. All this is made possible only for one reason, because one CPU any given time can communicate with only one device, one at a time is possible. Therefore, there is no point in connecting each one individually and making the whole system too complicated and making it messy. So that's why we do go for a bus system, and many more issues to discuss in this series. So keep watching. Thank you.